Hello, everyone. My name is Jeff Wilmington. I'm a technical product manager with the networking and security business unit here at VMware. Today, we're going to go through secure remote workers with VMware NSX and Horizon. And in this session, we'll cover all the ways in which the NSX platform provides simple, comprehensive protection for your Horizon VDI deployments. As we take a look at a little bit of our business realities as they stood, maybe a few years ago or so, the most common work environment models for organizations had been having employees come into the office and work. And when you secure the machines within inside the four walls, it was relatively easy to do, whether it was a laptop or a desktop type of endpoint from that perspective. But as our realities have started to, change over the last several years, we started to see an uptick in the office model shifting to allowing employees to work from home or anywhere for that matter, and work from the office, but also work from any device. And this has created some new challenges in building consistent security for both on-premises and external employees now that they're outside of the four walls. Organizations had started to, investigate adopting more consistent platforms such as, VMware Horizon endpoint, end-user computing deployments, to help standardize how employees access company resources. And so what this really meant was less dependency on the endpoint type. And so as times have started to change over, say, the last year or so, we started to see new realities where it just was not possible for employees to come into the office and work. And businesses needed to adapt quickly and either build net new end user computing environments or expand their existing VDI deployments. Businesses needed resources that were endpoint independent so that employees could continue working from outside of the office. Because if that meant that the employees were working from home, that might mean that they're using their home endpoints to do business. And to keep the business as running as much as possible, security constructs and consistency needed to adapt as well. Now we have these employees now working from home, and these recent events, such as COVID-19, where folks are working from home, more prevalent than they were in the past, have emerged some new threats to businesses. And we've seen exponential growth in the number of malware and phishing-related content being not only sent directly to employees, but also through other various means across the internet. And with so many possible new threats, just a single compromised desktop or endpoint can allow a malicious actor access to a business's most critical data. And so these threats used to be, simple to maintain, right? Within the four walls, they were very easy to kind of maintain. But now with employees kind of working from home to support the business, there's no more really security perimeter for a business. It's now grown outside of the four walls. And so east-west communication protection is now more important than ever from stopping lateral movement should an outside endpoint become compromised. And that is absolutely paramount for businesses. So what if you could build a security posture that would allow the granularity your business needs based on multiple types of, rich contextual information? What if you could secure communications based on who an employee is and what they're accessing and have the most granular security at the virtual workload level? What if you could take that security and apply it not only to the virtual desktop workloads, like this shows, but also, to the management and delivery and file services that are required to manage, the Horizon endpoint computing system? What if you could take that same security and in an elastic fashion, as your business expands, support this remote workforce consistently, granularly, and with rich contextual security is all applied and maintained? And so what that solution is, and what we refer to it as, is the security, the solution is a security premise we call microsegmentation. And the VMware NSX platform provides this very, very simply. So simple that it only requires a single firewall rule to isolate and protect lateral movement between desktop systems. So remember, these desktop systems are sitting inside your business's data center, right? VDI deployments are virtualized workloads that sometimes sit next to the server-based workloads within your data center. And those server workloads are running production applications and platforms for your business. So protection from unintended lateral movement or lateral communication needs to be maintained in a simple and efficient manner. As we can see in this example to the left, a single firewall rule can be applied to the VDI pool group and block all unnecessary desktop traffic to the machines in the pool. And NSX doesn't just stop at providing security for desktops, although that is a primary use case. We can isolate desktop pools from one another, right? So we can, if you have a contractor, have contractors, that have access to, have different access than your full-time employees. That's not a problem. You can isolate each pool with independent security policies. And as I said before, NSX has access to rich contextual information, such as which employee is logged into the VDI desktop or the remote desktop session host server. We can write individual policies based on this user information, based on who the user is, and allow, say, Bob, to access applications, HR in HR, or Alice to access engineering applications. And lastly, NSX has a rich partner ecosystem for inserting things like agentless antivirus with our Gets Introspection platform. Let's look at how this works from an end-user computing level. Bob is going to log in using his Horizon client. He's going to get a desktop clone. And that desktop clone is going to immediately get an NSX policy as soon as it's spun up. Or if it's already waiting, it's already got an NSX policy associated with it. Bob's going to get his applications from Dynamic Environment Manager, or he's going to get his applications from app volumes, right? So he's going to get his configuration, his file and profile information from all of those different sources, and that equals Bob's desktop. But this is, the same consistent policy, regardless of whether it's Bob, whether it's Lucy, or whether it's Max from development. Either way, any different user, we can provide a similar consistent policy or an individual policy based on the user from an NSX perspective. And with the service-defined firewall with NSX, which is the feature that is used to provide the segmentation capability, we could go beyond, just doing segmentation for the VDI environment. We can also segment the rest of your infrastructure. Single security solution for your entire infrastructure platform. End-user computing environments aren't just made up of just the components of the end-user computing system, right? Horizon is not just UAGs and connection servers, etc. There are external services, things like DNS and Active Directory, NTP, and certificate services that are necessary for those systems to continue to function. And NSX can provide security. We can control how Horizon interacts with all of those different systems and how those systems interact with Horizon to provide a similar consistent security policy across the board, regardless of whether it's just Horizon or it's your other infrastructure services as well. A common misconception that I get, I get questions, from the field or for people, outside of the organization is, does NSX require an overlay to do any of the security? And quite frankly, the answer is no. That's not the case. It is not a requirement that NSX has to have an overlay, or those machines have to be on an overlay to get the security-based services. NSX works in single or overlay workload VLAN, or single VLAN or overlay workloads, or multiple VLAN or multiple overlay workloads. It doesn't matter from our perspective. You don't need a overlay. It's not a requirement, although we obviously do support security if it is an overlay type of communication. NSX, we're going to take a look at some services here, and NSX is going to provide all the necessary services required for securing lateral communications for the end-user computing platform. Layer 4 services for things like ports and protocol support, and even Layer 7 application ID support for things like Horizon Blast or PC over IP. Those capabilities, those application IDs are in the NSX platform for you to write your security policies. And using those Layer 7 app IDs dramatically simplifies the policy writing process. We don't need to remember all these ports or write all these ports into our rules. We can just simply use the Layer 7 application ID protocol from there. NSX has, fantastic support for on-premises customers, as I kind of, showed a little bit here. But we're also extending support for end-user computing environments that are not on-premises, things hosted in the public cloud, such as Horizon Cloud on Azure. NSX can provide similar security benefits to public cloud desktop deployments as it does for on-premises types of environments. NSX brings segmentation to Horizon Cloud on Azure with the ability basically to automatically assign roles to the desktop, based on Active Directory group or tags or other types of attributes. And so this provides a similar and consistent security posture that a customer is accustomed to running on premises, whether they run it in Azure or not. And so control of east-west and lateral communications is achieved in a very, very similar fashion to how we do it on premises when we do it in Azure. So desktop pools can be isolated from each other, and the end-user computing, management components can be secured as well. Right now, we're going to go in and take a look at, a little bit around how to actually do this. And I have a demo here that we're going to walk through, and I'm going to show you a little bit about what we can do with the actual platform. All right, let's start this video here and go through our demo. And what we're going to do now is we're going to go through and show how a microsegmentation demo with Horizon. So we're going to secure virtual and remote desktop session pools. So right here we see we have a desktop Horizon Desktop 03A, and we have Horizon Desktop 04A, two different desktops in our environment. We also have a Horizon RDSH server from an RDSH host farm, and we have another one as well. So what we're going to do now is we're going to flip over here and we're going to log in to our Horizon client. You can see we have access to our Horizon desktop pool. So I'm going to click into my desktop pool, and I'm going to go ahead and open up a command prompt here and show you that we are logged into the 04A Horizon desktop. I'm going to do a ping real quick and show just how easy it is for me to be able to write a policy here. And as you can see, I can ping the 03A desktop in our pool, and we don't really want to be able to do that, right? We can do the same thing from here as well. We can log in to our Horizon desktop RDSH farm. I open up a command prompt, and you're going to see I'm logged into one of the RDSH hosts. And I'm going to see if I can ping the other host from an RDSH session. And you'll see that I'll be able to actually ping it, and communication is flowing between these systems. Now, I don't necessarily want to have these systems to have communication. They don't need to talk to each other. And so we want to limit lateral access and lateral movement within the data center. You can see that also from the RDSH server, I can ping one of the desktops as well. So let's just go in here and show how easy it is to write a policy. I'm in the NSX Manager interface, and what I'm going to do is I'm going to go into the inventory and go into groups, and I'm going to show you that I have a couple of groups here. I've created a group called desktops. I have members in here, and what I've done is I've created a criteria that says if the machine begins with HZN-DT, I'm going to add it to the group. And you can see now that 03A and 04A are showing up in that group. I go in, I have an RDSH criteria similar, and the effective members are both of the Horizon RDSH servers as well. Very, very simple, very easy to create groups based on names. I go into the distributed firewall here, service-defined firewall, and I'm going to create a new security policy. In this, I'm going to select the source as the desktops and the RDSH hosts. I'm going to apply it in, and I'm going to drag them into each other. I don't want these systems to be able to talk to each other at all. I drag them in, I apply it, I change the action to reject, so it's going to reject all traffic. Remember, we were permitting it before, and I'm going to publish this out. One rule, and now we're going to go back and take a look. As soon as I publish this rule, I now flip back over to my sessions, and I'm going to retry my pings. I'm going to retry my communication. You can see that with reject, I'm getting a destination host unreachable. I'm getting a response back basically saying you cannot communicate with that machine anymore. And I can do the exact same thing from the RDSH host as well. When I tried to ping the other RDSH system, I get no response. When I try to ping the desktop, even from there, I don't get a response either. And as you can see, one simple rule to block communications between those systems. But our pools expand and contract, right? So let's go into our Horizon here and let's go in and edit our desktop pool. I've got 2 in there. Let me create 3. Let me show you how easy and how elastic the security policy is with NSX. I've expanded my desktop pool to 3 from 2 to 3, and I'm provisioning another RDSH system as well. I've expanded my farm from 2 to 3 RDSH hosts as well. So I've expanded all of my security. So how does this, as my environment grows, I need my security posture to be able to follow that as well. As you can see, a new desktop was created, 01A, and you're going to see another another RDSA system being spun up as well. We can see 03A is being cloned and being spun up for access. Now, as these systems are spun up, my security groups in NSX basically had criteria that said if they began with a certain kind of name, right? So Horizon RDSH or Horizon-DT. When I go into my groups now and actually refresh my groups, I can see that the new system, the new desktop has matched and is now in the same security group. My RDS hosts, now that brand new system spun up, now inside the same group. Perfect. Every time I expand my pool, the security remains the same. I now can go back in and show that even if I expanded the pool and I go over here and I change this to the new machine, consistent security applied. Brand new system, never touched it. All I did was just spin it up in Horizon and I'm good to go. Same with the Horizon desktop with the RDSH system. I'm going to come in here, I'm going to try to ping that new system we just spun up, and boom, I cannot gain access to it. Again, consistent, reliable policy as soon as the machine is actually spun up. And I should not be able to ping that other new desktop from that RDSH system as well. Very, very simple, very consistent security policy. So let's take security a step further, right? I mentioned that, we can provide, NSX can provide, security using rich contextual information such as user ID for providing yet another layer of protection for Horizon desktop solutions or VDI deployments or RDSH deployments. So let's take a look at how NSX can do that. In-user computing platforms, provide customers with multiple options for presenting desktop services. And they come in, different form factors as well, either virtual desktops or remote desktop session hosts or RDSH-based systems where multiple users log into the same system, yet get isolated and individual desktop types of environments. Each one of these options presents a unique challenge, if you will, for providing security. And NSX can handle each of these use cases in a similar manner, in the exact same manner, in fact, by providing the ability for the customer to create and apply per user granular security policies, regardless of the use case. And so it also makes sense to define, where the end-user computing platform starts and where NSX kind of takes over. And for Horizon-based solutions, they control the access for the entitlements, right? They control which users are entitled to which systems, whether it's a desktop or an RDSH-based system. However, once the user is actually logged into those machines, NSX controls where that user can go inside or even outside of the network. And so all of this functionality is actually very, very simple to provide access to. In most cases, most customers already have it or have the capability of being able to do this. And this is part of the VMware Tools installation. When you do Horizon-based deployments, VMware Tools is a requirement. You have to have the VMware Tools actually deployed. So when you go and you actually deploy these desktops, you can enable some of these extra drivers, if you will, these extra capabilities within the VMware tools. If you do a complete installation, they're already there. If you don't do a complete or you do a typical, you can add these in very simply just by taking a look here at the screenshot. 2 drivers, and that enables the ability to for NSX to get information or to get the user information from the systems, and then use that information to provide security services. And after that, no other interaction is necessary by the customer from there. So, enough with the slides. I've been showing a lot of slides. Let's go to the demo and let me show you how we can actually secure Horizon Desktop and application pools, whether it's from an RDS farm or it's for published applications, how we can actually do that. So what we're going to do now is in this demo, I'm going to show how we can actually do the identity firewall with NSX and Horizon, both desktops for VDI and for RDSH. And as you can see, we going back, we have our same desktop systems, O1 and O2, and we have an RDSH base host system there as well, 03A. And what we're going to do is we're going to try logging in as different users. This is our engineering server, just a random server that we're going to try access to, and we're going to show how we can provide services. We go over to Active Directory, and I see I have an HR users group, and in that group, I have a user who is Bob. Bob is our HR user. Bob's going to get access to HR systems. Engineering users, we have Alice, and Alice is our engineering user, and she needs access to that engineering server, that Ansible server I showed you before. So what we're going to do now is I'm going to log in to my Horizon client, except I'm going to log in as Alice, and I'm going to put Alice up here on the left-hand side, and I'm going to launch it to the client as Bob. And we're going to log in as two different people and show how NSX can provide two different security postures for each of these different users in real time. So I have both Bob and Alice up here. What I'm going to do now is I'm going to launch a desktop pool with Alice. Alice is going to log into her desktop. And we're going to move it over here to the left-hand side. And I'm going to go in here and we're going to open up a command prompt here. And we're going to try to SSH to that engineering server as Alice. And Alice is going to get prompted for an SSH fingerprint. She hits yes, and all she has to do is type the password correctly, which apparently I can't. And now she gains access to the system. All right, Alice is in her system via a VDI desktop. Now Alice is going to log into an RDSH farm and get a separate RDSH desktop. And she's going to go in, she's going to open a command prompt, open up PuTTY actually, and she is going to attempt to SSH over to that same engineering server from the RDSH-based system. And she should have access to this as well, right? Because we did not dictate that Alice or Bob can't talk to these systems. We can also launch a published application or Horizon app directly from the RDSH-based server. I'm not even on a desktop, and I'm just launching the application. I log in. I'm still logged in as Alice. I can attempt to access the engineering server, and I have access to that server. Now we're going to go over to Bob. Bob is going to log into his desktop, very similar to how Alice did. He's going to log into his desktop and he's going to attempt to access the engineering server as well. When he runs a command prompt and SSHs over to the engineering server, Bob, who's an HR user, has access to our engineering server. That is not what we want to have happen, right? But we didn't place any security postures in place to prevent Bob from having access to that. So whether Bob is logged into a VDI desktop, or he logs into an RDSH host as he's logging into right now, Bob from HR can access the same engineering server that Alice can. And we just don't want that to happen. He can launch it from there, or he can do like Alice did and even launch an application as well. And so what we need to do now is we're going to do the same thing we did with the desktop pools and the RDSH-based pools. We're going to flip over to NSX here. And create a security posture for this. So when I flip over to the NSX manager, I need to actually add NSX to Active Directory. So I'm going to connect it to Active Directory to pull in the user groups. So when I go into inventory now and I go to groups, I could create a new group and see I have an engineering users group. And what I'm going to do is I change the group definition to pull in the engineering users group that I showed you before that had Alice in it as the member for these groups. So Bob is going to be an HR user. We now have an NSX security group that's associated with those Active Directory groups. We have an engineering server group that we created that has that Ansible server in that we want to provide and create access to. Now I'm going to flip over to security. I go to distributed firewall like we did before. And as you can see, I have an engineering users can gain access to the engineering server over SSH, and I'm going to allow. I also have a reject rule that says if you're not a part of those, then you can't have access to it. I enable, I publish, and now what we're going to do is I'm going to flip back over to the sessions I had open. Alice should still be able to gain access to the engineering server now that our rules are in place, because I said that the engineering users can attach to an engineering server. But I declined everything else. I denied everybody else. When Bob tries to get in there, remember Bob had access before? Bob, as an HR user, he should have no access to this engineering server. There's no reason why he should be able to get in. When Bob tries to SSH, he is going to be rejected. Rejected, connection refused. He's on his desktop. Now let's flip over to RDSH. I had both those systems as the destination or as the source, and so it doesn't matter from my perspective if Alice is logged into the RDSH based system. I published it. I published my rules. I immediately got security posture in place. Alice, good to go. Bob is going to get rejected. He tried to go in through PuTTY to the engineering server, and he gets connection refused. Published application, similar approach. Alice and Bob both going to try to log in. Alice is over here, Bob over here. Bob's going to try to log in via published application. Bob gets rejected as well. Connection refused. Alice, perfectly fine, logging in, has access just as we would expect. And that's how simple it is. Very simple, very similar to how we did the normal security rule, except now we actually were able to control it via user ID and take it even a step further. All right, so let's take a step back here, and we can see that there are 4 distinct capabilities that NSX provides for end-user computing environments. Distributed microsegmentation, where every workload can be secured using a per workload and a per user granularity. We saw on both demos. User-based policies that provide security for VDI or RDSH-based desktop formats. Whichever, bring it, we can do it. Compact object model, where the customer can just specify the actual desktop object or attributes. You saw we used attributes of the object, right? Where we said if the name of the object was HZN-DT or HZN-RDSH, whenever those machines were either there or spun up, immediately dropped into the appropriate group. And we were able to create a security posture or a security policy that can be done even by just using a single rule, isolating those desktop types of communications. And lastly, centralized control. I didn't go anywhere else other than maybe the Horizon interface, but that was mostly just to spin up the new desktops. But I didn't go anywhere else except in NSX to actually create that security posture. I didn't have to go to a different console or any place like that. I just went through the NSX manager, and it has total visibility across all those workload environments, regardless of type or regardless of location. So, where can I learn more? What resources do you have, Jeff? And there are several online places, at your fingertips to access and get further information. We have several demos, we have white papers, and even reference architectures that incorporate all the things that I talked about today. I want to thank you very much for your time and hope you enjoy the rest of the VMUG. Have a great day.